So this is the final section in Chapter 1, and we're solving compound inequalities. And compound inequalities occur when we have two inequality signs, which is essentially two comparisons happening simultaneously. We also utilize compound inequalities when we have an absolute value inequality. So we'll see both of those in this video. So first of all, we have 1 is less than or equal to 2x plus 3, which is less than or equal to 11. So think of these two inequalities separately. So here's the first one, and here's the second one. And I'm going to write them separately and solve them separately. So 1 is less than or equal to 2x plus 3. 2x plus 3 is less than 11. Remember, when we get our answers, we're going to pick a number that will make both of these true simultaneously, because this is written as one single sentence. So if 1 is less than or equal to 2x plus 3, I'll start by subtracting 3 from both sides. 1 minus 3 is negative 2, which is less than or equal to 2x. Divide by 2, divide by 2. Negative 1 is less than or equal to x. So consider the logical equivalence here. If negative 1 is less than or equal to x, then read it backwards. X is greater than or equal to negative 1. So that's the first inequality. Here's the second one. 2x is less than 8. Divide by 2, x is less than 4. So we're looking for a number that's bigger than negative 1 and less than 4. So this is going to be a conjunction of sets when we put this on the number line, and we'll also give our answer in interval notation. So here's 1, 2, 4, 6, negative 2, negative 4. So that means negative 1 is going to be about right there. So this would be a closed circle on negative 1 because our answers are greater than or equal to negative 1, and our answers are strictly less than 4. So this is a conjunction of sets, or an intersection of two sets here. So this is very easy to put in interval notation. Remember, if we are including the negative 1, that will be shown with a bracket. We are not including the 4, that will be shown with a parenthesis. So our interval goes from negative 1 to positive 4. So we can pick 0, which is in the solution set, and putting 0 back into the original inequality should make it a true statement. So is 1 less than or equal to 2 times 0 plus 3, and is that less than 11? So 1 is less than or equal to 3 because that cancels, and that is equal to 11. So it's true. So that is a compound inequality. Next problem. The absolute value of 5 minus 2x is greater than 7. So consider where the absolute value of 7 gets bigger, or what's bigger than the absolute value of 7. So obviously everything to the right of 7, or everything to the left of negative 7. So the farther that you get away from 0, the greater the absolute value. So we're going to use this idea to set up our two inequalities here. 5 minus 2x must be greater than positive 7. Remember, because everything to the right of positive 7 has an absolute value greater than 7. Or 5 minus 2x must be to the left of negative 7, so less than negative 7, if we want an absolute value that's greater than 7. So this isn't going to be a conjunction of sets, this is going to be a disjunction of sets. So let's solve for both intervals here. So 5 minus 2x greater than 7. So minus 5, negative 2x is greater than 2. Divide by negative 2. Once again, we're dividing both sides of an inequality by a negative. That will flip the inequality sign. So x is less than negative 1. So this is our first solution set or first interval. Other side, 5 minus 2x is less than negative 7. So minus 5, negative 7 and negative 5 is negative 12. Once again, we're dividing by a negative, which will flip the inequality sign. So what was less than is now greater than. Greater than what? 6. So these are our two intervals. If we put them on the number line with there's 0, there's negative 1, there's 6. So open on the negative 1 and everything less than negative 1. Open on the 6 and everything greater than 6. So it's like the two trains are leaving the station going in opposite directions. This is a disjunction of sets. And this time, instead of choosing a number that we know will make it true, let's choose 0, because when I plug in 0, it should make it false. It should make it false because 0 is not in the shaded area. So when we plug in 0, we should get a false. So let's be on the lookout for that. So 5 minus 2 times 0 is greater than 7. So the absolute value of 5 minus 0 is 5. Is 5 greater than 7? No. That's why we get a false, because it's not in the shaded area. Therefore, it will not make it true. If we plug in 10, it would 5 minus 20 is negative 15, and the absolute value of negative 15 is greater than 7. So anything to the right of 6 or to the left of negative 1 will make it true. Now let's finish off this problem by writing our answer in interval notation. So this time, we don't just have one interval, we have two. Interval notation is read from the left to the right, so it will be negative infinity to negative 1, union, positive 6 to positive infinity. Two infinite sets come together to make the solution for this inequality. Last problem. The absolute value of 2x plus 6 over 3 is less than 2. So think about, again, on the number line, where does the absolute value become less than 2? Well, it's going to be as we get closer to 0. So as we get closer to 0, the absolute value is shrinking. If we get farther from 0, the absolute value grows. So this allows us to set up our two cases here. So 2x plus 6 over 3 must be less than positive 2. 2x plus 6 over 3 must be greater than negative 2. We've got to be to the right of negative 2, which is greater than negative 2, or to the left of positive 2. So let's see what we get here. So first of all, this is a fraction. And fractions are our friends, but we want them to leave the party as soon as possible. So to get these fractions to leave the party, we are going to multiply both sides by 3. The 3's will cancel, and we end up with 2x plus 6 is less than 6. So from here, minus 6, 2x is less than 0. Divide by 2, x is less than 0. So here is one set. X must be less than 0. To the other side, same procedure. Get rid of the 3 by multiplying both sides by 3. The 3's cancel. We get 2x plus 6 is greater than negative 6. So this time when we subtract 6, we're not going to 0. we are going to be greater than negative 12. Divide by 2, divide by 2, x is greater than negative 6. So we're looking for numbers that are less than 0 and greater than negative 6. So we're expecting the two trains to come together at the station, creating a conjunction of sets. So, on our number line representing our solutions, we've got a 0, let's put 0 here, and a negative 6 here. We'll put negative 8 over here and a 2 over here. So, our solutions, and this is strictly less than, strictly greater than, so open circles, shading in the middle. And a number that is in the middle, we'll say is negative 2. So if we let negative 2, and we're going to check it right here, by letting x equal negative 2, we should get a true statement. So we're plugging in negative 2 into the original inequality. So 2 times 2 plus 6 over 3, is this less than 2? So let's see, that's 4 plus 6, which is 10. And 10 divided by 3, oh, negative 2. Negative 2, Hendry, negative 2, so it should be a negative 2 right there. I was about to have an error, which would have been tragic, but thankfully I have my handy-dandy correction tape. So 2 times negative 2 is negative 4. Negative 4 plus 6 is 2. And yes, obviously, the absolute value of 2/3 is less than 2. So it checks. Negative 2 is a solution. So finally, in interval notation, our solutions, open circle, so parentheses on both sides. So our solutions are in the interval from negative 6 to 0. That is solving absolute value inequalities.